Welcome, data architects and engineers. Today, we are exploring a powerful capability within the Snowflake AI data cloud, the Cortex-enabled cross-region parameter. Let's get started on optimizing your AI workloads for availability and capacity. Let's begin by defining exactly what we mean by cross-region inference. In machine learning, inference is the process of using a model to get an output based on user input, such as passing a prompt to an LLM. By default, Snowflake processes these requests within the cloud region where your account is hosted. However, the Cortex-enabled cross-region parameter changes the game. It is an account-level setting that allows your inference requests to be processed in a completely different region. Why is this important? Because as Snowflake rapidly releases new state-of-the-art models, they may not immediately land in every single global region. When enabled, if a requested LLM or feature isn't supported locally, Snowflake automatically routes it to a region that does support it. By default, this parameter is disabled for most legacy accounts, but for new commercial accounts created after March 9, 2026, it defaults to any region, offering frictionless access from day one. Take a look at this decision flow. When a user submits an inference request, Snowflake first checks if the requested model is available in the default local region. If yes, it processes normally. If no, it checks the Cortex-enabled cross-region parameter. If the parameter is disabled, the request unfortunately fails. However, if it is configured to allow other regions, the system dynamically routes the workload to an alternate region, processes the AI request, and returns the result to the user seamlessly. Why should enterprise architects prioritize enabling cross-region inference? The primary driver is model availability. The AI landscape moves at lightning speed. If you are operating in a European or Asia-Pacific region, you might find that massive models like DeepSeek, R1, or the newest Claude 3.7 Sonnet are only hosted in specific US hubs initially. Enabling cross-region inference instantly unlocks these frontier models for your team. The second major benefit is capacity scaling. Snowflake explicitly grants much higher rate limits when cross-region inference is enabled. For example, your tokens per minute, TPM, and requests per minute, RPM, limits can double for heavy workloads, preventing throttling during peak usage. Most impressively, Snowflake absorbs the networking overhead. You do not incur any data egress charges for cross-region AI requests. Finally, it unlocks higher-level services like Cortex Analyst and Cortex Search in regions that currently only support them via this cross-region architecture. This comparison diagram highlights the immediate upgrade your account receives. On the left, a local-only setup restricts you to standard rate limits and a limited model set. By moving to the right, cross-region enabled, you instantly unlock boosted token and request limits, gain access to the entire global roster of Snowflake models, and do so without incurring any data egress fees. It is a massive architectural advantage for high-scale AI applications. Let's discuss the how. Configuring this parameter requires the account admin role, as it impacts account-wide data routing. You modify this using the alter account set Cortex-enabled cross-region SQL command. You have three primary configuration strategies. Setting it to any region provides maximum flexibility, allowing Snowflake to find the fastest, most available region globally. If strict data residency is legally required, setting it to disabled ensures no inference request ever leaves your local region. The sweet spot for most enterprises is the third option, specifying exact regions. You can pass a comma-separated list, such as AWS US, Azure EU, meaning Snowflake can only route to those specific geofenced cloud environments. For our government users operating in US SnowGov, you must explicitly set this to AWS US, as cross-region inference is highly restricted and cannot cross into commercial public internet boundaries. This state diagram illustrates your configuration choices. As an administrator, you execute the alter account command, branching into three paths. You can choose any region for maximum availability, disabled for strict data residency, or a specific list of regions. The specific list gives you controlled routing, allowing you to balance compliance with access to cutting-edge AI features. Security is paramount when data moves across regions. Let's do a deep dive into how Snowflake handles data routing during cross-region inference. If your account is in AWS Europe and it routes to AWS US, the data never touches the public internet. It stays entirely within the AWS global network backbone and is automatically encrypted at the physical layer. The exact same applies if both regions are within Azure. However, if your request routes from an Azure region to an AWS region, the data will securely traverse the public internet utilizing strict mutual transport layer security, or MTLS. The most critical security guarantee Snowflake provides is zero data retention. Your user inputs, your proprietary prompts, and the generated model outputs are never stored or cached in the destination region. The compute happens in memory, the answer is returned, and the data vanishes from the remote region. Follow the data path in this flowchart. Starting at the source region, Snowflake checks if the destination shares the same cloud provider. If yes, it routes safely over the provider's isolated global network. If no, it secures the payload with MTLS over the internet. Both paths arrive at the inference compute node. Once the result is calculated and returned, the final and most important step is triggered: absolute zero caching or storage of that payload in the remote region. Your intellectual property remains secure. As senior professionals, we must manage the economics of our architecture. How does billing work when compute happens somewhere else? Snowflake simplifies this brilliantly. Credits are always considered consumed in the requesting region. If your database is in US, East 2, but the LLM runs in US, West 2, your bill reflects usage in US, East 2. Furthermore, Snowflake absorbs the data transfer costs. You do not incur any data egress charges for cross-region inference. However, physics still applies. Routing data thousands of miles across the globe introduces network latency. While the models are blazingly fast, the transit time will add milliseconds to your response. Therefore, Snowflake highly recommends running latency tests for your specific, real-time interactive applications before moving them to production. You can monitor all of this activity and token consumption seamlessly using the Cortex function's usage history view. This diagram illustrates the economic mechanics. Your account in the EU West region sends a request to compute resources in US East. US East processes it and returns the output. Look at the resulting impacts. The billing happens entirely locally in your EU West account, and there are strictly zero egress fees applied. The only architectural trade-off you must plan for is the added network latency on the far right. Let's explore how this parameter impacts the broader Cortex ecosystem. It's not just about raw LLM functions. Cortex Analyst, our text-to-SQL engine, fully supports cross-region routing. In fact, for optimal Cortex Analyst performance globally, Snowflake recommends pointing your cross-region parameter toward AWS US regions. For Cortex Search, enabling this parameter is absolutely mandatory if your account resides in specific regions like Paris, Zurich, or Singapore, as search is only available there via cross-region compute. However, there is one critical limitation you must memorize: cross-region inference does not support custom fine-tuned models. Because fine-tuned models rely on your specific custom adapter weights stored in your registry, inference must take place in the same region where the model object is located. If you need a fine-tuned model in another region, you must utilize Snowflake database replication to physically copy the model object to that new region first. This hub-and-spoke diagram clarifies feature compatibility. As you evaluate a Cortex feature against cross-region support, you'll find that standard Cortex LLM functions, Cortex Analyst, and Cortex Search all follow the yes path. However, Cortex fine-tuned models follow the no path. As indicated by the dotted line, solving this limitation requires utilizing Snowflake's robust database replication to move the weights closer to the compute. Let's solidify this with a highly practical real-world use case. Imagine an enterprise operating strictly out of the AWS Europe, Paris region. They have a mandate to build an advanced retrieval augmented generation, or RAG, chatbot using Cortex Search and the Claude 3.5 Sonnet model. The immediate problem is that Cortex Search is not natively hosted in the Paris data centers. Without our parameter, the project stalls. The solution: the Snowflake administrator executes the alter account command, setting the Cortex-enabled cross-region parameter specifically to AWSU. The result is immediate. When the application issues a Cortex Search query, the workload is seamlessly and securely routed to a nearby European region like Frankfurt or Ireland that supports the compute. The enterprise gets their state-of-the-art chatbot, avoids data egress fees, and critically, keeps all data processing strictly within the European Union compliance boundary. This sequence diagram details our RG chatbot scenario in action. The application in Paris queries the local Snowflake account. Snowflake checks for local Cortex Search compute and fails. However, recognizing the AWS EU cross-region configuration, it instantly routes the payload to the Cortex AI infrastructure in Frankfurt. Frankfurt processes the vector search and returns the results. The local Snowflake account then delivers the final, intelligent response back to the chatbot application, all in a fraction of a second. To conclude, here are your best practices for managing cross-region inference. First, always audit your defaults. Run a show parameters command to understand if your account defaults to disabled or any region, so you don't encounter surprises. Second, always test latency. If you are building a real-time conversational agent, benchmark the cross-region response times to ensure they meet your UX requirements. Third, embrace strict governance. Instead of using any region, use a specific, comma-separated list of approved regions to ensure data only travels to locations your legal team has cleared. Finally, stay updated on Snowflake's release notes, as models are constantly rolling out to new regions, which will naturally optimize your workloads over time. Thank you for joining this deep dive. I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final workflow diagram illustrates the lifecycle of cross-region management. You start by auditing the parameter state. Then, you define your geofences using a specific list of regions. Next, you thoroughly test application latency. Once in production, you monitor your usage history. By following these steps sequentially, you arrive at the ultimate goal, a highly optimized, compliant, and performant AI workload.